Hello. In this video, we're going to do principal component analysis using the R programming language. And for this, we're going to use the same data set that we used in the Excel spreadsheet. Now, in reality, it's not going to be the exact same data, and the reason for that is because I was using a random number generator to come up with my values. So when I copied the data from Excel into this file, it of course the random numbers changed. So every time you open up that file, the Excel file, it's going to be different. However, the relationship between X and Y will be the same because I've got a complicated formula that will describe the relationship between X and Y. So anyway, the punchline is that the variables or the values might be different, but the relationship should be very similar. I guess this is really my way of saying that don't sweat it too much if these numbers aren't perfectly the same. Okay, so let's just read this data set in, the X and the Y data, and there they are. That's X and that's Y. And these are the values that they have. Now, what we need to do principal components, the command, there's no special library to load in, so all we do is we run principal component, give it the data set, and center, set that to true. What that really means is minus, subtract out the mean value. Okay? And then scale, set that to true. What that means is that we are going to, when we set that scale to true, what that means is that we are going to divide by the standard deviation. So let's run that command right now. And if I do PCA, then these are the principal component analysis. And you can see that in this case, principal component 1 has a minus and a minus. The other one was a plus and a plus. It doesn't matter. The signs are different. And this one has a plus and a minus. But these are the two principal components. And if we do a summary of these guys, you can see that just as before, the first principal component is worth 98% of the data, and the second guy is only worth 1% of the data. And so let's plot this guy, and if we can even plot the eigenvectors here, well, in this case we only have two eigenvectors, or eigenvalues, excuse me. And you can see that eigenvalue, the first guy is a value really, really close to 2. So remember, the value was 1.96 or 1.98, something like that. And that means that that first principal component has enough information in it that it's capable of describing as much information as two variables. The second guy is about as useless as no variables. So we could probably do most of our analysis just using one principal component. So anyways, this is how you do principal component analysis using the R programming language. And just for fun, I added a little bit of extra code. I stopped the recording and added a little extra code here. And what I'm going to do is I'm going to take this principal component model that we built, and I'm going to score our training data using this guy. And I'm going to put the new information right here. So let's do that right now. And if I type new train, I have the principal components for all those values. And if I want to, I could copy the first column from new train and put him into principal component 1, and this guy, and I'm going to create a variable called principal component 2, and I'm going to attach both of those guys to the old data set. So let's do that. And there you go. So if I have 8 and 8.6, the principal component for this guy is minus 1.4, and the principal component for this guy is negative 0.11. So there, that's how it's done. So that's it. Bye-bye.